In this video, we are going to create a basic metal material as you see here. This video is designed for users who are brand new to Substance Designer and its workflow. We will cover some key basics and finish up this material in the Part 2 video. At the end of this two-part Getting Started series, you'll have a basic understanding of how to create base materials in Substance Designer. To begin, we're going to go to the top of the UI and choose File, New Substance. In the New Graph dialog wizard, you'll notice that we have a set of templates. We're going to start here by using the physically based metallic roughness template. Here for the graph properties, we're going to set a name, and let's just call this metal. We're going to leave everything else at default and then click the OK button. So here in the Explorer view, this creates what we refer to as a package. A package is a Substance project file that has a .sbs file extension. Notice here that I have my package and I can see this, and right now it's set to unsaved, and below this we have the metal graph that we just created. We can visualize this graph here in the graph editor. For now, let's just save this package. So here I'm going to select my package and click the Save button. And I'm just going to place this on the desktop for now, and I'm going to call this metal.sbs. Again, notice that it has the .sbs file extension. So let's click Save. And now our package is called metal, and it contains a graph called metal. Now, here in our graph editor, you'll notice that we have 4 nodes by default. These are the nodes that were created for us when we chose the physically based metallic roughness template. These nodes are the output nodes, which create the 2D textures that this substance will generate. We can view these 2D textures here in the 2D view. Now, if we want to navigate here in the graph, we can simply hold down the middle mouse button and click and drag to pan the graph viewport. If we need to zoom in and out, we can hold down the Alt key and right mouse button to zoom in and out. Here we have our 3D view. Now, to make sure that we're all on the same page, let me reset my 3D view. So I'm going to come here to Camera, and I'm going to choose Reset. So again, here we have a 3D object here in our 3D view. If I want to navigate this view, I can hold down the left mouse button and click and drag to rotate the view. If I hold down the right mouse button, I can zoom in and out by just moving the mouse up and down. And if I need to pan, I can use the middle mouse button to pan. Now, we have this geometry here that's loaded into the viewport. If I come over here to my Geometry tab, you'll see that we have a list of predefined meshes that we can use when designing our substance material. Now, as I stated earlier, Substance Designer is designed to create these base materials, and you can often just use the default meshes that ship here with Designer. For example, here we're using this rounded cube. You can import your own geometry as well, but for this video, we're just going to focus on using this default rounded cube. Now, I'd also like to talk here about materials. So when we click this Material tab, you'll notice that this says Default. What this name relates to is the material ID that's associated with the mesh. Now, in our case, this is just this basic piece of geometry, and its material name is just called Default. If I look at this pop-out menu, you'll notice that I have this definitions option, and this is referring to the shaders that we can use here in Substance Designer. Notice here that the physically based metallic roughness is what we have enabled. This is because we chose the physically based metallic roughness template when we created our substance. So what we have here is a mesh. The mesh is using a physically based metallic roughness shader. The substance that we will create will have these texture outputs, and these texture outputs, which become 2D textures, are fed to these shader inputs so that we can visualize the material here in the 3D view. Let's start creating our base material. Let's start by creating our first node. So here I'm going to hit the space bar, and this opens a pop-up menu that has a list of all of the atomic nodes, or what I refer to as the operational nodes. These are the core nodes of Substance Designer. And I'm going to come down here to Uniform Color, and I'm just going to left-click to select it. Now you'll notice that this node has been placed here within our graph. Let me zoom in here on this node, and you'll see that we have, again, this uniform color. So over here, you'll see that we have the parameters view, and every node has a set of base parameters. We control things like output size, format, and tiling mode. And then each node is going to have its own specific parameters that are going to relate to what the node actually does. So in this case, we have a uniform color, and you'll notice that it has a color mode, and it has an output color. Now, I can just click and drag here in this gradient to select a color, or I can click this swatch here to open the color editor and choose a color. Notice here that we have a color selected, and then here on our 2D view, we are viewing the texture that's going to be generated by this particular node. Now notice we don't see anything here on our 3D view, and that is because we don't actually have any connections here to our outputs. They are all blank at this time. So what we want to do here is we want to create this basic raw metal. And so instead of coming in and using this uniform color and selecting kind of the appropriate metal reflectance range here, I'm going to use a different node. So I'm going to come over here to my library, and you'll notice here that under Material Filters, PBR Utilities, there's a node here called PBR Metal Reflectance. And I'm going to left click and drag and drop this node here into the graph. Now, the nodes here that you find in the library are what we refer to as custom nodes. These are nodes that were created within Substance Designer using the core set of nodes. And I can demonstrate this. Again, let me just zoom in here into the viewport, and I'm going to right click this selected node here, and I'm going to choose Open Reference. So this is going to ask me, do I want to load the package which contains this graph reference, and I'm going to click OK. And so you'll notice here that this node is actually comprised of another uniform color that's connected to an output. If I select this color here and I come over to the output color, notice that we no longer see those color value settings, so we can't choose a color. And I'm going to click this button here, which is referred to as a function button. So I'll just click this, and you'll notice here that we have a new tab that opens here in our graph editor, and now we see a bunch of nodes here which represent a function graph. Now, we're not going to get into this in this video. This is an advanced topic, but the main takeaway from this here is that nodes that you find here in the library are going to be derived from the core nodes that you create here in Substance Designer. That means that you can create your own custom nodes and tools here within Substance Designer and extend it in any way that you need. So let's go ahead and just close this node out, and let's go back to our main graph. Now also notice over here in our Explorer view, we've got two packages now. We have our metal, and then we have this PBR metal reflectance node. Now remember, when I opened that reference, it asked me if I wanted to load that package. We don't need this anymore, so I'm just going to right click and I'm going to choose Close. Okay, so now that we have this PBR metal reflectance node, we're going to set some of its properties. So notice here again we have these base parameters, but this particular node, again because it's a custom node, it has instance parameters. And that is because when you drag and drop a node into a graph, we refer to that as instancing. And it has a specific kind of custom UI here that allows me to choose a metal reflectance value. So here I'm going to choose iron. Now let's make our first connection here to our output. So I'm just going to left click and drag this node kind of into position here, just so that we can get a clear idea of what we're doing. So notice on this node that we have an output. So all nodes are going to have an output. Again, if we take a look at that uniform color that we created earlier, it also has an output. Notice that this output has a yellow color. That indicates that this particular node is going to output color information. And that's what we want here for our base color output. So let's make a connection between these two nodes. Now all I have to do is come over here to the node and just left click and drag out, and you'll see that I get this connection line. Now I can come over here to the base color and I can just plug this right in and let go of my mouse. That makes the connection. Notice now that my output color now has value. Also, you'll notice that we saw a change here in our 3D view because we supplied one of our output nodes here with some information. Now, if you didn't see a change here in your 3D view, you can just right-click an empty area here in the graph, and you can come over to this option, View Outputs in 3D View. And when you do that, you should be able to see some information. Like I explained earlier, this information here from the output node is generating a texture, which is feeding into the channel inputs of the shader for this particular 3D asset. Okay, so we've started to set our first connection here. Now we want this to be a metal, so what I'm going to do is just move down here to where we see our metallic output. Let's grab this uniform color that we've already created and utilize this. Now notice I have the node selected, but I don't see its output here in my 2D view. That's because in order to view something in the 2D view, I need to double click the node. So now I've double clicked the node, and now we can see its information here. The reason why we have this set up is because I can view an output, but I can move back to another node, do a single click to view parameters on one node while I'm viewing the output of another node. So let's again come back here to our uniform color. I'm going to single left click it once more just so that we can view its parameters. Now I want to set this to be a raw metal, so we need a grayscale value. So I'm going to come over here to the color mode and I'm going to choose grayscale. Now we have a grayscale slider, and like I said, we want this to be raw metal, so I'm going to take this slider and just drag this all the way to the right until we hit 1 or 255. So now this is going to indicate that this material that we're working on is raw metal. Let's make another connection here to our metallic output. Let's left click and drag to get the connection node from the output of that uniform color node and connect it here to the metallic. When I let go of the mouse, you can see here that the viewport updates. Now we have a very shiny metallic surface. So what we want to do now is add some roughness information to this. So here I'm just going to pan my viewport up to where we see the roughness, and I'm going to supply some roughness information. Now another way I can do this is I can just have this node selected and I can just copy and paste the node. Let's do that. Let's hit Control C and Control V to copy the node. So now what I'm going to do is select the node and I'm going to make a connection to my roughness output. Again, left click and drag the output and plug it right here into the input of the roughness output node. Okay, so now when we do that, you can see that since we're using a value of white or full white here, we are simulating that this surface material is completely rough. So all of the reflection is very diffuse. So what we're going to do now is select this node and just start to drop this roughness value. And as we do this, you can see that we get varying degrees of roughness. As I bring it closer to black, we get a little bit more of a glossy look. Now, here's another thing that I want to talk about. If I zoom in really close, you'll notice that we have some artifacting here around the edges. And that's because we don't actually have any normal information that we're working with on this material. So let's do this. Let's move up to where we have our normal output, and sure enough here, our output is blank. So what I would like to do is just add some normal information so that our shading will be correct. And I don't actually have any normal information just yet. I just want to use a blank normal. Well, I can do that by just grabbing one of the nodes from Substance Designer. So to do that, I'm going to hit the space bar. And here in this search field, I can quickly search through all of the nodes that are in the library. So what I'm going to do is start to type in normal. And here you see that we have a list of these normal nodes here that we can use when working with normal information. What I would like to do is use this normal color. So I'm just going to left click to create this. And what this does by default is just give me a blank normal. So here I'm going to make the connection here to my normal output. And when I do that, you can see that we're now feeding normal information, which corrects the shading error that we had. So now we have just a basic metal material. So at this stage, we have a very basic material and it's pretty boring. So what we're going to want to do is start to augment our roughness map so we can add a lot of surface detail. So let's just move down here again, just painting the graph where we have our roughness. And let's just pull this node a little bit out of the way. And what we're going to do is we're going to place a grunge map into this area. So again, we can get some really nice intricate variation here to our roughness. So over here in the library, you'll notice that I have generators and here I have this noises. So here I'm just going to adjust the UI a little bit so I get a little bit more room here. So you can see I'm just moving or expanding this thumbnail view. And here in this search field, I'm going to start to type grunge. And we have several of these kind of grunge map textures. I'm going to grab this grunge map 12. So I'm just going to left click, drag and drop, and place that here into the graph. So now I have this grunge map. Let me zoom in here in the 2D view. And again, I can do that by holding down Alt and right mouse button and zoom in, and I can pan by using my middle mouse, and we can see some of the details that we have here in this grunge map. I'd also like to point out that here in Substance Designer, all the nodes that we're creating are set to tile by default. So here, let me just adjust my viewport again. So I'm just maximizing a little bit more here of my 2D view, and I'm just zooming out. Now, if I'm in the 2D view and I hit the space bar, now this brings us to this kind of tiling mode so we can see how the texture is going to tile. If I move my mouse out of kind of the 0 to 1 space, here you can see the full tile of the textures. So if I want to disable this mode, I can just hit spacebar. Now, again, this is just for kind of visualization here of the texture. Hitting the spacebar doesn't mean I'm creating a tile from the texture. It's already doing that automatically. Now, here our node is selected. Remember when I told you every node has a base parameters, and one of those base parameters is tiling mode. If you'll notice that here by default, it's set to horizontal and vertical tiling. So here I'm just going to come back to my 2D view and hit the spacebar just to kind of turn off that tiling mode. So now we have this texture that we want to use, and I'm just going to make a connection here to my roughness. So I'm just going to left click, drag out the connection line, and replace that uniform color. So now when we look at this here in the 3D view, our object here is being, augmented by that grunge map, and it's really, really rough. Now, this particular grunge map, like I said, is a custom node that's built from other nodes here within Designer, and there are instance parameters that we can use. So I can control some things like maybe my balance or my contrast. But these controls are not really giving me what I want to do. What I would like to do is kind of remap the value ranges here in this grayscale map. And I can do that by using a simple levels command. If I hit my spacebar here, you'll notice that we have a levels node. This again is the atomic or operational node. This is one of our core nodes. So if I select this node here, it adds the levels here to the graph, and I could start to make a connection like this. So now I have a levels node that's inserted between my grunge map and my output. This means that we can have the grunge map, so I'll double click to view that in the 2D view. Then we'll go to our levels, double click. We can process it here with this histogram, and then that result will be fed here to our output. So you can see that we have this flow of the graph, starting from the base, the levels, to the output. So here, just to show you a couple different ways to connect a node, let me select this node, and I'm going to hit the backspace key on the keyboard. That's going to delete the node, but retain this connection line. So here, I can just left click and just drag a selection box over this connection line to select it. Notice that the line becomes a bit thicker. That means that it's highlighted. And now I can insert a node or add a node to my graph, and it's going to automatically be connected between the two nodes. So another way that I could create a node is here at the top of the graph, we have this little toolbar. And here you can see that we have the level button. So let's just click this button. And you can see that, again, it inserts that level node here in between the two nodes because I had the connection line selected. Now, like I said, I like to process some of these value ranges. So what I'm going to do is come over here to my output white and just start to drag this down. And I'm going to take my output black and move this up. And so now I'm getting kind of a more subtle effect. Let me just rotate my model here in the viewport. Now, another way that we can kind of work with our 3D viewport is that we can rotate the environment. So what I'm going to do here is hold down my Shift and Control and right mouse button and drag left to right to rotate the environment. Now, speaking of our 3D view, we can also change this environment. So here in my library, if I just scroll down to where I have 3D view environment maps, let's select this, and you can see that I have several HDR environment maps. Now, you can actually import your own maps, and we'll cover that in a different video, but for now, what I'm going to do is just come over here to a map such as this glazed patio, left click and drag and drop it right into my 3D view. And what that does is updates the environment map that's being used to light my scene. So again, if I hold down Shift and Control and my right mouse button, I can rotate here the environment. So here I'll go back to my levels and just make a few more adjustments here. So I no longer need this uniform color node, so I can select it, and here I'm just going to hit the delete key. So now I'd like to add some details to my normal map. So let's come over to this section here where we have our normal output, and I'm going to come over to my library under patterns, and I'm going to utilize this mesh 1 pattern. So let's left click and drag and drop this here into our graph. Now for this pattern, you can see that the scale is pretty large, so let's adjust this tiling parameter, and I'm going to set this to a value of, let's say, 10. And I'm also going to enable this rotate 45 degrees. And so this gives me the pattern that you see here. So essentially what I've done is create a height map for this pattern, and I'd like to convert that into normal information. So for now, let's take this normal color and let's delete it. We don't need that anymore. And here, I'm going to hit my space bar, and I'm going to grab hold of the normal node. And what I'm going to do is take this height map and plug it into the input of the normal node. So now I'll just double click to make sure I'm viewing this node here in my 2D view. Now we're seeing some transparency, and I don't like that here in the 2D view. So I'm going to click this button, which enables alpha for an image. So we're basically just going to turn the alpha channel off so that we can clearly see this normal map. And here for my intensity, I'm just going to drag this slider here all the way up to 3. Now notice that this slider looks like it maxes out at a value of 3. However, any slider in Substance Designer, I can simply just double click to enter a numeric field and then enter a new value. Let's just say 6, and I'll click enter, and now you can see that the value is 6. My slider will now go from a value of 0 to a maximum value of 6, which is the last value that I entered. Now we don't want that to be actually 6, so let me just again pull this down to close to 3. And so now I have my normal. Let's take this normal information and plug this into the normal output. So I'm not really happy with how soft this shape is. So here, let's zoom in on my 3D view, and you can see how soft this shape is. So what I'm going to do is just make a little bit of room here between my Mesh 1 node and my normal map. I'm going to select the connection, and then I'm going to click this Levels button to add a levels. And now I can just adjust my levels, input black and white, to adjust the value range here of this height map. So this here gives me the effect that I'm looking for. Now, up until this point, we've been working with a resolution of 256 by 256, and you can see that here as denoted underneath all of the nodes here in the graph. Now, we can disable this resolution display by coming up here to the top of the graph bar, and you can see that display node size is enabled. So if I uncheck this, I no longer see the node size unless I roll over one of the nodes here. So let's just go ahead and keep this display node size enabled. And like I said, so far we've just been at 256 by 256. Now, it's very important to understand how resolution works here in Substance Designer. Resolution is inherited. A node will inherit resolution from its input or from its parent. In the case of a parent, I'm talking about the root level graph. So if we take a look at all of the nodes that we have so far in this graph, these nodes are children of the root graph, which is our metal graph that we created. In order to look at the base parameters of this root graph, we simply need to just come over to an empty area and just double click. Now we are at the root level of our metal graph, and we can now adjust the output size here. Notice that our width and height has a value of 0 with an indication of parent times 1. At this setting, we get the value of 256 by 256. Now that resolution is determined by the parent setting. So for example, if I come over to this button and I click this, you can see that we have two modes, relative to parent and absolute. And we are set to relative to parent. Now, even though we are at the root level of our metal graph, the substance itself, when published, can be used in a host application such as Unity or Unreal Engine 4. At that stage, the host application is then referred to as the parent. Each host application has its own default resolution. And for this example, here in Substance Designer, the default is 256 by 256, when the output size is set to a width and height of 0. Now, when you publish your substance, you're going to want to make sure that the root level of the graph is always set to be relative to parent at a level of 0, 0. You do this so that you can set the appropriate resolution in the host application. So let's take a look at how this works. So here we are in Substance Designer. So in our particular case, this relative to parent is talking about the root level of the graph. That is our metal graph, and all of the nodes are going to inherit that resolution. So let's take our width and height and let's set this to a level of 1 and 1. Notice now that we are at parent times 2 and that the resolution has changed for each node to 512 by 512. So we've multiplied that parent resolution by 2. So remember, in Substance Designer, that is a default parent resolution of 256 by 256. And so now at parent times 2, we get 512 by 512. Let's move to level 2. So parent times 4, we take the 256 times 4, and we get a resolution of 1024 by 1024. Again, all of the nodes are inheriting the resolution from the parent graph, which again, in our case, is this metal graph. So changing our relative to parent size gives you an idea on how the resolution is working. However, we always want this parent resolution to be set at parent times 1 so that the resolution is set correctly through the host application. So what we do is we just set this back to 0 and 0. And when we start to create our substance, we want to change this to absolute mode. Now, under absolute mode, we can set the desired resolution that we want to work with. So again, here, I'm just going to move this to 10 by 10, and that's going to give me a 1024 by 1024 pixel image. So this width and height setting is just a level for a doubling of resolution. Let's just pull this slider here back to 1, and you can see that we are at 2 pixels. So if I go to level 2, we're now at 4 pixels. Level 3, we're at 8. Level 4, we're at 16. Again, we're just doubling this resolution. So here at level 10, you can see that we're at 1024 by 1024. So again, the workflow is that when you create your substance, you set the mode to absolute, and you work at the highest resolution that you think you're going to need so that as you're creating your textures, you can see a nice high resolution details and make sure that your textures will be generated correctly. And once you are finished authoring your substance, what you would then do is set this back to relative to parent so that you can publish. Now, one last thing that I want to cover with resolution is the relative to input setting. So to demonstrate this, let's go back here to our absolute mode, and let's just set the graph here to 1024 by 1024. Notice again, the resolution of every node is at 1K. So now let's select this mesh 1 node, and here I'm just going to zoom in here into the viewport. So we see this group of nodes. So like I said, we have this node selected, and the base parameters that we are looking at are for this mesh 1 node. And like I said earlier, we can change the output size for each node itself individually. So let's do this. Let's now set this to be absolute. Now, we have a setting here of absolute 256 by 256. Notice that we've set this node to be 256, and it has caused all of the nodes following it here to be 256 as well. Now remember, we set our root graph to be 1024 at absolute resolution, so the other nodes here are still at the 1024. Now the reason why this is happening is because of the relative to input setting that each node has. So now let's come over here to this levels, and you'll notice that its output size by default is set to this input times 1. So if I click this button, you can see that we get relative to input, relative to parent, and absolute. We've covered absolute and relative to parent, but this relative to input means that this node is going to inherit its resolution from its input, which in our case is this mesh 1, which is set to an absolute resolution of 256. By setting this node to absolute, we're basically overriding the parent's resolution at 1024. Now, our normal node again is set to the same input, so relative to input setting. Now, a common workflow when optimizing your graph would be to set some nodes at a lower resolution so they generate faster, and then let the subsequent node use the resolution of the parent. And it's easy to set up this scenario. So in our case, we're just going to select the levels node, and we're going to switch it from being relative to input to be relative to parent. Now, when we do this, you'll notice that we get 1024, 1024 for our normal, and 1024 for our output. However, our mesh 1 node is generating its pattern at 256. Now, just to further demonstrate how this is going to work, let's double click to get to our root. Let's switch this here to be relative to parent. So now it appears that everyone is at 256. So now let's change our parent resolution. So here I'm going to set this to, let's do a level 3 by 3, and that's going to give me a 2K resolution. So now notice that our node that we set to be absolute is still at 256, and then it increases resolution to 2048, with the levels node because, again, that levels node is set relative to parent, and our normal node is still set to relative to input. So it's grabbing its resolution from our levels node. So the key factor to understand with resolution is that a node will inherit resolution from its parent or from its input. And we can control that here with the settings of relative to input, relative to parent, or we can set the node to be absolute resolution. Substance Designer allows you to create textures in a non-destructive workflow, and that is apparent here in that we can dynamically change resolution. At this point, we have a simple base metal material. Let's take a break and pick things back up in part 2, where we will further explore the texturing paradigms in Substance Designer.